So today we're going to build this. We'll start by adding a bunch of stars to the scene, and then we'll add points to each of the vertices of that cube and apply a shader material to those points. That allows us to map these textures that we'll load. Because it's on the GPU, it's just really performant. Let's get started. First thing I want to do is import get starfield.js. Okay, save, and there should be no errors. Let's add it to the scene. So const stars equals get starfield, and we'll pass 4,500 stars. And then we'll add the stars to the scene. Scene.add stars. And we should have some stars. Right now, each one of those looks like a tiny little box. And we can change that by creating a texture loader, then loading const star texture, or we can call it star sprite, is equal to texture loader.load, and I've got this image in the project called circle.png. Now I can pass that as the sprite to my get starfield method, and now instead of little boxes, those will all be little circles. See what I mean? Let's add points to this son of a gun. I want to create a points material, and then I'll create a points object and pass in that box geometry and that points material. Const points material equals a new 3.points material. And let's leave it absolutely empty for now. Const points equals new 3.points, and pass in the geo and the material. Scene.add points. Save. Oh, and we've got the points. So the points material without anything passed to it looks like that. Kind of weird, I'd say. You know what else is weird is that the points stay there while the cube moves. But let's tweak the look of the points. It is green? No, it's that color. I forgot what color that is. What's FFFF? It's green plus blue. It's not yellow. It's not purple. Orange? It's not orange. Cyan? Oh, it's cyan. Duh. Size is equal to 0.1. And let's fix that rotation. I don't love that. By creating a group, and we'll add everything to the group. So const globe group is equal to a new 3.group and scene.add globe group. And now we animate that instead of the cube. And let's just animate the y-axis. See how that looks. Ah, yes. Now the points and the globe move together. We can create a separate geometry for the points and for the globe, for the mesh, like so. I'll just create another geo. Let's call this points geo. And we can add detail. So 3, 3, 3. And that didn't do anything because I didn't swap it out yet here. Okay. And let's go ahead and make that mesh, make it a mesh basic material, and tell Three.js we want it to be a wireframe. Yeah, like that. Now we're getting somewhere. I feel like it's rotating too quickly for me. Now it's rotating nice and slow. I can greatly increase the detail in the points geometry. I could, for example, const detail is equal to 20, and then wherever I'm using a 3, just replace that with detail, like so. And now I have a lot more of those little points And let's, if we see them better, we reduce the size, we can see them a little bit better. Now that we've reduced the size, we can increase the count a little bit more. And I'm going to load a texture. I don't know if this is actually going to work, but I'm going to try. Const color map is equal to this earth map 10K. And I think I can pass that to the points material, but I'm not sure. Oh, I know I can. Is it a map property? Yeah, that's not going to work very well. Oh, it actually kind of works. Let's get rid of that color. Yeah, it kind of works. That's so cool. I'm just dropping the color of the wireframe down to like a really pale gray and increase the point size slightly. Look at that. We've mapped this earth color texture right here to the points that are populating this globe. Make it slightly more sparse, lower resolution, and that's really horrible. Let's swap out the geometry. Make this slightly smaller. Yeah, like that. Let's swap this geometry out and see what happens. So instead of a box geometry, I want to do an icosahedron because I love icosahedrons. And for the geometry, I want this to only be detail of 10. And excuse me. For the points geo, let's continue our pattern of passing detail like so and see what happens. Oh wow, look at that. Let's crank up the detail a little bit. Yeah, isn't that nice? Slightly smaller points. Yeah, pretty cool, right? I wonder if I made this transparent. That's not good. And then drop the opacity down a bit to 0.1. I'm just curious what that would look like. You can't even see it at all now. All you see is the points. So all this has been done so far just using a points material and a texture loader. Next steps, I want to get rid of the points in between the continents. So we just have the continents, and I want to add the elevation. Okay? To do that, we're going to use a shader material instead of a points material. And this opens Pandora's box to shaders. But buckle in. I don't think this will be too complex. I hope not, because the effect is really cool. You can even add interactivity. Hang on. Using a shader. This is outside the scope of this lesson. Maybe I'll add it in another one, where I'm passing the mouse coordinates down to the shader, actually UV coordinates, and then the shader responds accordingly. How cool is that? But for now, we just want to get that shader material up and running. Let's replace that points material with a shader material. Here's how I want to do it. I just broke it. I'm going to first create a vertex shader. A vertex shader is a little program you pass down to the GPU along with a fragment shader. Let's just show what it is. I'm going to communicate with it from my JavaScript file, and I'm going to pass it this size parameter. So a uniform is a type of variable that you can pass into the shader. Every shader needs to have a main method, and in the case of the vertex shader, we need to set the position. I need to calculate this. This projection matrix is built in, but the MV position, model view position, is something I'll calculate. And I also want to set the point size, because these are points. Apologies for the hand wavy shader overview, but the effect is cool, and this is an entry into shaders. Next, the fragment shader. also needs a main method. And in this one, we're going to define the frag color, which is kind of loosely equivalent to the pixel color. So every pixel has its own shader running on it. And the frag color represents that. It's a loosely connected to pixel. So I need to calculate the color and the alpha. And in this case, I'm not passing any uniforms. Okay, next we need to define those uniforms. So that's in JavaScript. We'll say the size. We're just going to define the size uniform. That's going to be the size of the point. Next, we create our shader material rather. I want it to be transparent, and I'm going to pass in the uniforms as well as those two shaders, the vertex shader and the fragment shader. That's it. If I save, I have a bunch of points that are all green. Isn't that horrible? Let's see if our uniforms are hooked up properly and shrink those points by half. Yeah, it's working. And a lot more. So a bunch of tiny points. Yeah. A reminder that the number of points is defined by this detail. Right? I'm just passing the icosahedron to the points, and that's using the icosahedron's vertices as the point positions. Okay. You could change the color to red, like so, or white. All right. Let's do something interesting. Let's load a texture. Actually, we already did load a texture, this color map. Let's use that color map. I'm going to create a new uniform, and this one will be called color texture. And I'll use the color map. In my vertex shader, I'm going to pull that in. Do I need it in here at all? I don't suppose I do. Let's just add it to the fragment shader first. Uniform sample 2D color texture. Thank you, GitHub Copilot. And now I'll just say for the color, texture 2D, the color texture and the UV. I don't have a UV in the fragment, I believe, so I need to pull it in from the fragment shader. This is where I talk about a varying. A varying is a value that you share between the shaders. Again, apologies for the hand-wavy nature of this shader overview. I'm grabbing the UV from the vertex shader, passing it to this varying, and then pulling it in here, varying, and then using it here. And I really only need, actually, no, I need RGB. Let's apply that. And you can see the color. Let's increase the detail to 80. I could even go to 100. Because it's on the GPU, it's just really performant. I don't know, how about 160? And it's just a nice high resolution. I'm at 200. So much detail. So cool. Let's increase the point size ever so slightly. Yeah, look at that. Now, I want to hide all of the areas that aren't land. And the way I'm going to do that is to use another texture, this one. First thing, let's just load that up. Wait, where am I loading? Here, okay. Const, what am I calling? Elevation map, but I really want it to be elev map. It's this earth bump. Okay. Create a new elev texture is the elev map, and I'm gonna use it in both shaders, I think. Actually, no, I'm not gonna use it in both shaders. I'm only gonna use it in the fragment shader. I'm gonna calculate float elev equals the texture 2D. This pattern should look familiar. And this time I'm only grabbing the R channel. I only care about one. They're all the same. All three channels are either black or white. So that's all, like, yeah, if they're all the same. Now I'm going to change the MV position.z. I'm going to push it up based on that texture. Let's see how that looks. Oh, look. See how the points are kind of pushed up in the areas where mountains should be? Oh, so cool. That's so good. Great. Moving right along. We're going to load another texture. Let's just load all the textures. Const. What is this one? Alpha sprite. Did I already load that? No. Alpha. I'm going to call this alpha map. Yeah. And load the earth spec. Create a new uniform. And we'll call this alpha texture. I think that's pretty clear. And we'll pass in the alpha map. All right. The vertex shader needs this one. Uniform. I'm waiting for GitHub Copilot to catch up. Sampler 2D. Alpha texture. Correction. The vertex shader doesn't need it. The fragment shader needs it. And we'll calculate the alpha with texture 2D alpha, and we only need the R. And let's see how that looks. Boom. We only have the water. Kind of. It looks really cool. There's some weird artifacting because I'm using an icosahedron. Let's invert this. And I love how easy it is to invert this. 1.0 minus. Boom. Look at that. How cool is that? I don't like the look of this. I'm just gonna turn off the transparency and make it just kind of a light gray. How cool is that? Last thing I want to talk about today is how to hide the points on the other side of the Earth. Because right now it's like a transparent globe, but I want the continents on the other side of the globe to be hidden, and that'll solve this weird artifacting I'm seeing, where you can see like these black points here, and then you can't see them there. To do that, I'm going to create a new varying, a float called vVisible. And apologies for this paste, but I don't really know what's happening here. This vVisible is step 0, and then, yeah, I don't know what this means. I don't know what any of this is. If you know, please leave a comment. But it works, I know that. So in the fragment shader, I'll pull in that varying vVisible, and then I'm going to use it. Actually, I'm going to do this. If vVisible is less than 0.5, I don't know if that's going to work. Let's see. Oh no, I think I blew it up. Yeah, I made a mistake. It's really unhappy now.
A few moments later.
What's going on, man? I really broke this. And I'm not sure how I broke it. Okay, so I broke it because I copied and pasted that vVisible, but I didn't define vNormal first. And vVisible is based on vNormal, so let's save that and see what happens. Ah, now it's working. And you'll notice that the points just plain old disappear as they move beyond front facing. As they move to the back, they just disappear. So we've hidden the continents on the other side of the planet. Pretty cool, right? Wow, if we had more time, we could play around with this a lot and try a bunch of different things. What kind of things? We could try different colors. Let's just do that real quick. So for the color map, I'm going to replace that with a file I've included in the project, rainbow 10K, and now we have a rainbow earth. A fun one to replace it with as well is earth lights. This one here. Let's see. Copy that. And now we get the earth at night. How cool is that? Is it even visible? I love all of the detail. So much detail. Other things you could do is try some interactivity. I'll probably cover that in another lesson. Try different geometries instead. Like try a sphere instead. Let's try that real quick. Instead of an icosahedron, let's say a new sphere geometry. And what does that take? Sphere geometry takes, let's see, it takes a radius of 1. It takes width segments, height segments. Yeah, let's do 10 and 10. And then down here, we'll do 1 detail, comma detail. And drop this down first to 30, which is going to be impossibly little. Crank it up to 100. Oh yeah. And now 200. I don't know. I like the sphere layout too. Let's put this back on Earth map. Whoops. My bad. $300. The thing about the sphere is I don't feel that the points are distributed evenly, but they are in a nice grid. See, on the top they're really packed together, and at the equator less packed together. Still really nice. You could either pump up the point size or the detail. Let's go to 500. They say it shouldn't be done. Oh, look at that. It's pretty great. Yeah. That's it for this lesson. I want to give a big shout out to everyone who supports me over on Patreon. Your support helps me create a new video every week. Thanks so much for coming by, and I'll see you in the next one.